Hello and welcome to my video lesson 3.3 on stretches. So looking at this type of transformation, first of all, just looking at our general form of the transformed function, we have the a outside the f of x part, and we have the b inside. And those are the two values we're going to be looking at today. So a and b will reflect the graph if they're negative values, which we looked at in lesson 3.2. But now we're looking at them as if they are big numbers or if they are fractional numbers. So if a is bigger than 1, then the y value will change. Because it's closer to the y's, it changes the y value, which means there will be a vertical stretch. If a is greater than 1, less than 1, then it will still be related to the y values, but a vertical compression. Basically, it'll squish it vertically. On the other hand, the b values, if b is greater than 1, it will be a compression. So it's a reciprocal version of what a does. And if b is less than 1, then it will be the horizontal stretch. So because b is next to the x, it changes the x values. And this is important. So if it's next to the x, it changes the x values. If it's next to the y, it changes the y values. Okay, let's look at some example questions. So we might have to zoom out a little bit for this one. There you go, I think that's enough room. So the parent function of y equals square root x. So I drew that parent function right here. So what will it look like if we stretch it in different directions? Well, here the a value is 2. So what this is going to do is it's going to stretch it vertically, and it's going to make it bigger vertically. So every y value is going to be doubled. So we can think about this in a few different ways, but maybe one way we could do this is to just look at our table of values. We have 0, 0, then we have 1, 1, then we have 4, 2, then we have 9, 3. So if our y values are being doubled, then our x value and our x values stay the same. So 0, 1, 4, 9. So doubling everything, we get these values. So just doubling it, that was 2, so this should go to 4. This was 3, so it should go to 6. Okay, so everything has been doubled in the y direction. Now if we take a look at the other function, and we'll look at domain and range in a second, but if we look at the other function, the x values are being divided in half. So the y values all stay the same, but the x values have been divided in half. So it should look something like this. Okay, so 0, 0, yes, no problem. 0.5 and then 1. 2 and then 2. 4.5 and then 3. So let's see, maybe we can get another one after that. So 16 and 4 would be the black version. So if we divided that in half, that would be 8 and 4. So they look remarkably similar. So sometimes the stretches in the x or the y direction can actually end up being pretty much the same. And that is dependent on if the function has been translated basically in any direction. If it's been translated in any direction first, then the x and the y's will make a bigger difference. Or if it's a more unique function, let's say, where it's not symmetrical. So anyways, that is what we would do here to get those domain and range. Oh, that's not what I want to do. I want to select all this stuff. And maybe just move it up here. Okay, so the domain and range of the different functions, well, for our original one, x has to be greater than or equal to 0, and y has to be greater than or equal to 0. And actually, none of these equations have changed at all in that regard. They're all the same way. Okay, let's take a look at another example question here. It's going to look a little bit different. And that's, so what I've done here is the parent function I've drawn in black, and it is down 1 from what it would be. So what are we doing to get to the blue function? Maybe we should just keep that as negative. What are we doing to get to this blue function? Well, what we're doing is we are adding the b value, multiplying to the x. Okay, so that means another way to do it, instead of looking at the table of values, is just look at each of the points and take the x value and multiply it by 2. Okay, so we're actually going to be stretching it horizontally, multiplying it by 2. So right now, -3, so it's -6. So this is -2, so it's -4. This is -1, so it's -2. This is 0, so it's still 0. And so everything just kind of gets stretched by just doubling the x values. Okay, and now the red values, well, what's happening? The y values are being squished. So we're taking every point and taking the y value and squishing it by 1/2. So it used to be 8, so we're going to squish this to 4. This used to be 3, so we're going to squish it to 1.5. This used to be 1, so we're going to squish it to -1, so we're going to squish it to 0.5, sorry. This used to be 0, so that can stay 0. Okay, this used to be a 3, so 1.5. This used to be an 8, so 4. So can I imagine what, 16, 15, so 7.5 could be our other one. So every y value has been halved. So it just gets squished vertically. So one thing to notice in a function like this is actually that our transformations look like they're kind of similar, because this one could be changed to y equals, and if you square that, you get 1/4, and then you get x squared minus 1. So it looks kind of different, but it really is actually going to end up the same result. So if you take a 1/4 approach, right, then it should give you the same answers. So 1/4 of any of these points should give you the same answer. So just interesting to note that there are ways you can translate it kind of differently, and you'll get the same thing. The only reason why it doesn't work in this case is because of these -1s. They cause a little bit of confusion in this case. Okay, it's your turn. Here we have an absolute value function. So this is the parent function, that's what's drawn. There is a vertical and there is a horizontal transformation, a stretch. So go ahead and try to draw this. I'll pause the video, go ahead. Or you should pause the video and try this out. Okay, our first one here in blue is a horizontal stretch. So if it's 1/2 for the b value, that means you're going to actually double it, take the reciprocal. So times everything by 2. Okay, so whatever horizontal point that there is, it's just timesing by 2. So you can take any one of those points and just times by 2. So it'll look like this. So let's draw this out. All right, so it should look like this instead. Okay, whereas our vertical situation, what's happening is we are multiplying our y values by 3. So wherever we have a y value, we times it by 3. So our first one is 1. Our second one is 2 times 3 is 6. Third one is 3 times 3 is 9. And it'll be the same thing on the other side. Okay, and it'll look something like that. So again, we here it's a vertical stretch. Of 3, whereas the last one was a horizontal stretch of 2. All right, I hope this video helped you understand this topic a little bit better, and good luck.